This is episode number 39 with neuroscience researcher and clinician Stefanie Faye, whose research is focused on brainwaves, heart rhythms, and micro movements that influence our ability to self-regulate and build healthy relationships. Welcome to the Neuroscience Meets Social and Emotional Learning podcast. My name is Andrea Samadi. I'm a former educator who's been fascinated with understanding the science behind high-performance strategies in schools, sports, and the workplace for the past 20 years. Each week, we bring you an expert who's risen to the top of their industry with specific strategies that you can implement immediately, whether you're a teacher or student in the classroom or working in the corporate world to take your results to the next level. Now, I've got to give you a bit more background on Stefanie Faye. Her graduate research at New York University and fieldwork at the NYU Phelps Lab for Neuroscience Research, the NYU Institute for Prevention Science, and Yeshiva University's Albert Einstein College of Medicine focused on the cross-section of self-directed neuroplasticity, empathy, and social justice. For the past decade, she's been teaching and consulting in countries all over the world by combining scientific insights and her training in monasteries with meditation masters from India, Africa, and Vietnam. She's delivered a series of workshops for Google's Analytical Academy in London, Chicago, Tel Aviv, Munich, and Singapore, focused on the science of learning. So she's a perfect fit for taking everything that we've been doing to that deeper level. Stefanie, I'm so grateful to have you here today to share some of your fascinating research with our listeners.
I'm so honored to be here. You're doing really exciting work, so thanks for having me.
And one night I was just researching and trying to get a deeper understanding of growth mindset. And then that led me to your Mindset Neuroscience podcast and your interview with Maria Zenadu on how to develop a growth mindset. And I was just blown away by how you took the neuroscience and connected it to social emotional skills and made everything seem so simple. So I'm so excited to dive deep into this with you.
Thank you. Thank you. It's an exciting place to be. People are really interested in this. So,
Stefanie, I'm going to get right into the questions. So when I watched your Mindset Neuroscience video course, I thoroughly enjoyed the way you connected neuroscience to building a growth mindset. And we've covered growth mindset on this podcast with episode 20. We did strategies for overcoming obstacles and cognitive biases. And I mentioned in that podcast an EdWeek survey that found that the vast majority of educators believe a growth-oriented mindset can help improve student motivation, commitment, and engagement to learning. But the study found that applying those ideas to practice and helping students shift their mindset around learning remains an elusive challenge. So applying growth mindset has proven to be something that's not been simple or easy to do, whether in the classroom, workplace, or even in the field of athletics. So with your background and experience, why is applying growth mindset proving to be so difficult? And what's happening at the brain level?
Well, yeah, I have quite a few answers for that. The first thing, especially since you mentioned athletes in your question, I think what I have seen is that people are talking about growth mindset. So they're treating it as a concept, and they're using words to try to convince people to, I guess, adopt a growth mindset. And part of this issue is that if we're really thinking about what growth mindset represents, it represents this idea that we can use our brain in new ways. It's not too late to learn. We can build new circuits. But what we kind of forget about all that is that that's something that we can feel in our bodies. There's something visceral about learning. And we're also seeing in a bunch of research that when it comes to learning, there has to be an experience behind it. It cannot just be a verbal exchange. It's not just about someone talking about something and people just listening. Because not only is it not relating to how we learn, which is an experiential, visceral thing, but everyone is going to come into a learning environment and hear about growth mindset and be at a very different level about what they can actually even conceive of conceptually. If we're using things like growth mindset, that's a metacognitive idea. And not everybody, especially young people, But most people aren't necessarily going to absorb that kind of information immediately. So talking about it and having words about it isn't always going to kind of touch the nerves that we need to touch in people. And so for me, part of what I've seen evolve through my teachings of growth mindset, first of all, the one thing that I say to a lot of people is that I was talking about this idea of neuroplasticity, of using our brain in new ways, of firing up new circuits for years before I'd ever heard of the word growth mindset. I'd never heard of that before. And so I never talked about growth mindset. I never used those words. And I actually think that that's something I would encourage people to do sometimes when they're introducing this idea, is not even getting into that, because that's a concept, and a concept is abstract. It doesn't mean anything to us. But if you talk about the brain and how it's building new circuits, and then relate that to an experiential, embodied experience, sensation, or something like that, I think that that is where people can anchor the idea when they're first learning about it. So examples that I give are things like when you're learning like a sport, there's kind of a muscle memory to it. But I'll bring it into the classroom, and I'll have people think about and experiment with the idea of even picking up their bag with a different arm, like their non-dominant arm, for a couple of weeks, to see how they can actually retrain circuits, mind, body, brain circuits. I'll have them do an experience right away in the beginning of a presentation, after I've talked a little bit about circuitry and neural circuitry, to kind of feel, for example, clasping their hands in one way, and then feel what it's like to clasp them in a very different way. Mm-hmm. And to actually feel that one way is something that's very familiar. We have a lot of myelination, a lot of circuitry built around that. And the other way is not incorrect, and it's not impossible to achieve, but it feels uncomfortable because we don't have that circuitry. All the different thresholds of our senses kind of say that this is not right. This isn't how we need to do it. So I try to always bring that in first to a learning environment when we're talking about growth mindset. People have to feel it. They have to relate it to something, and something that is in their body. We're getting very brain focused, and we're forgetting that the body is very, very much a part of learning. Not just these gross big movements like this, but tiny little micro movements of how we write, how we actually even have our ear muscles change as we listen, visceral sensations in our body that happen as we learn when we achieve something. So I think that's one of the biggest missing pieces for growth mindset right now, is making it about talking about it as a concept and forgetting the role of the body and sensations and sensory experiences, visceral feelings, and our embodied way of learning things. So I think that's one of the first things that I think can help people as they're trying to teach this idea of growth mindset. Get whatever you can to get some movement and some body-oriented sensory experiences into the idea of growth mindset. And what I would say is that leads into the second missing piece, is that a lot of people that are teaching it have heard about it, and they so get it. They are so excited about it. They understand that that there's something very true about this idea that we aren't born with a fixed amount of intelligence. We can grow it. We can grow our talents. They get all excited about it, but they are still missing the step of figuring out how they are in that moment, in that space of their life, learning something new, so that they can then figure out, what are the feelings of learning something new? What does it feel like to make a mistake and then pivot and then refine? Because as soon as someone gets to that place where they're truly, truly experimenting with new things, becoming a beginner, being self-conscious about making mistakes, it becomes very genuine, and they start to be able to relate and have their own ways of talking about it that are very natural, instead of hearing about it from somebody else and using somebody else's words. So that would be the second piece, is that I don't know if it's authentic enough when a lot of people are presenting it, because as much as excited they are about it, they're not necessarily becoming self-aware in that space where they are right now, of what it feels like to be a beginner again, what it feels like to learn. So bringing some awareness, if you plan to teach the idea of growth mindset, figuring out, even you, for example, learning about learning about growth mindset is something new for you. Mm-hmm. So trying to have some awareness of how it feels to be in that space. And what are some things that you do to, when you don't really know what you're talking about and you feel embarrassed about that, what do you do to pivot? What do you do to get through that piece? So those are two big ones for me, of why it's not working. Forgetting about the body in the role of learning and experience, not being an experimenter of doing new things. And then actually one last one is that the research is actually showing that bringing neuroscience into the presentation of growth mindset is the key. So growth mindset interventions that don't talk about the neuroscience don't seem to really go very far. The ones that have a very clear focus on the idea of neuroplasticity, how to explain how the brain learns, those ones tend to do better when they're looking at the research on it. So,
well, I can totally see why. And it was interesting for me because we've been implementing it with our kids. You know, my husband's in the education field, so we've heard about Carol Dweck and we thought, oh no, we've been telling our kids they're so smart over here. So we got rid of that, and now it's like, let's keep trying and use our efforts. So we got there. But then just taking it a little deeper, I realized I had a false growth mindset. So I thought about myself, you know, if you were to ask me, oh, do you have a fixed or a growth? I thought I'm definitely a growth mindset person. And then I realized that when problems happen, I definitely go back to, oh no, my old fixed mindset. And then I realized, oh no, I still don't have this mindset thing. And that's when I started trying to find out, well, what am I missing? And it is the neuroscience piece, because we default back to our old ways of thinking, and we've got to constantly be pushing ourselves to get back on track with this. So I can see why it's not working. When I saw it in myself, I was like, oh, I for sure thought I was growth mindset all the time.
And I think too, what you're touching on is also that to acknowledge that this is a spectrum, and that this isn't, we don't have a growth mindset about everything. We can have a growth mindset about certain things, and then not about our relationship with our parents or our kids, or, so as soon as we start to default into the idea that something can't change or evolve is kind of, hinting to the fact that we may be leaning on the fixed mindset side for one area of our life. So I think we have, different mindsets for different things. So what's cool is that you had the self-awareness to think about that, and to want to learn and be open to learning more about it, which is really cool.
Yeah, and I think I do see that why there's some missing pieces, because it's not just about, let's talk about having a growth or a fix. That's not where it ends. So,
and I would say too, to add on that, two things. One is that I started to pick up that people were using it as a judgment. So they were starting to judge somebody for having a fixed mindset. So it started to become an area that could induce shame. And I think that that's really going against the idea of what growth mindset is supposed to be about. And the other piece too with the neuroscience is that what I think neuroscience does is it gives people something tangible to picture, rather than it just an abstract concept. It's something that they can actually picture within themselves. So I think that's the other part that's really helpful.
Definitely, to help with our awareness and help us with self-esteem as we move forward and tackle difficult problems. Well, in your video, of course, you talk about some keys to building a growth mindset. And one of them is to understand neuroplasticity, or the ability for our brain to continually change over our lifespan, and creating high priority pathways with skills that we're practicing, and then eliminating low priority pathways with skills that we ignore. Can you explain this part with how the brain rewires using myelin, and why patterned repetition is so important at the brain level for skills that we want to improve, develop, and keep?
Yeah. Well, I mean, something to think about in terms of the brain. First of all, change is expensive. The brain is an efficiency. The mind, brain, body system is an efficiency machine. So change requires very expensive material like enzymes and myelin. And the brain is the mind, brain, body system. I always include all of it because it's not just about the brain. The brain is just receiving information from the body and the senses. So this is an entire biofeedback system. So that's really important to remember. But so change is expensive, and the brain is not going to spend material just flippantly. It's an efficiency machine. It likes to conserve energy whenever possible. And it is going to need to see, it's also a statistics-based probability machine. That's what our brain is doing. It's processing events, what's happened, it's making connections, associations, and it's looking to see what it will be able to predict for the future. That's one of the most important mechanisms for our survival. Will we take in information, stimulus and data, figure out what to do with it, and then be able to predict what's going to happen next, and if we can use that information for next time to survive and also thrive, and also kind of project ourselves into the future. That is the mechanism of our mind-brain-body system. So it needs statistics, it needs probability, it needs to know this in order to devote its resources to different areas. And so the idea of patterned repetition is this idea that it's not just sporadic or one-time thing. That can still make change in our body. We especially know this with traumatic events, that can be stored, and it's stored deeply in our cells, and in different parts of the brain that aren't even explicit. We're not always aware of that. So, big events can create massive change in our mind-brain-body system. But for the most part, when we're consciously trying to create change, when we're trying to learn, our brain has to see that we're doing something at a new level, that we're doing something new enough times in order for it to be able to even devote that kind of expensive material to those new circuits. So, in terms of the brain, when we're looking at myelination, we have different circuits that get developed, which is this idea that as circuits fire together enough times, the brain basically kind of promotes those circuits as high priority, because it's seeing that circuitry is needed in order to navigate whatever that environment is, because that environment is clearly has this stimulus in it, this challenge, whatever it is. And so in order to continuously survive in whatever this environment is, the brain needs to make that reaction and that association efficient. So it starts to devote this, different resources, but among them is something called myelin, which is this white fat. And that just basically, it helps preserve the energy of the signal firing across circuits. So as the electrochemical signals are firing across neurons and networks, the myelin is something that helps cover the axon, like the fibers, so that the signal doesn't get dissipated outwards. So then it starts to do something called a saltatory conduction, which is more of a jumping. It speeds through instead of kind of going in waves through, and then lots of the signals can kind of dissipate out. So it's like a covering over a cable in order to allow for the signal to go faster. So that material is something that the brain is only going to devote when it sees that signals are being fired enough times. It doesn't make sense for the machinery and the statistics of the body to do anything for one random event, because that's not necessarily going to help our survival. And it's all about efficiency and that idea of probability and predicting what's going to happen next. So I would say, that's kind of an overview of this idea of why that patterned repetition is so important. And if you look at it just, let's say people often use weightlifting or, muscle building as an example, that if you're using your muscles in a new way, doing one push-up or one, arm curl your body isn't going to devote anything to that. That's not signaling to the body enough times that this is the level that you're going to be working at. So it's basically saying, when you do something enough times, doing something new in a patterned, repetitive way, the mind-brain-body system is saying, oh, we're doing this now. This is the new level we're at. Okay, we'll start to devote some resources to that, because it's looking at that. It's a price. There's a price to pay for all the material that it sends out to different circuits and networks. So, yeah.
That blew my mind, because we all know the pain of doing something new, right? When we do something new, it's difficult, it's challenging. It's like, oh, I'm never going to figure this out. Like even with an exercise program, you do a new exercise, everything's like, what am I doing? Where do I go? And then before we know it, after a month, we can do it without thinking.
Yeah. Yeah. It's lots of different, there's different components. It's not just the myelin, but definitely the myelin is a big part of it. And just, yeah, in terms like glucose, there's brain glucose that's needed when we're doing something new. It's very exhausting for us to do new things. But like you were saying, we, even if we're learning to drive or learning to ride a bike, it requires so much activity, especially in this frontal area of the brain, a lot of brain glucose. Just it's very resource intensive to do something new. And so the only way the brain wants to kind of use up resource, because it likes just humming along, because that is the most efficient way to keep going. Just keep things as they are, keep status quo as it is, which is why change is difficult for all of us, because the mind brain body system is designed to be lean and efficient, and that requires it to preserve and conserve resources as much as possible, so that it does have something that in case we need it for later. So it will always try to kind of push us or give us the feeling that change is hard, because for the body it's expensive. So we have to, so that actually brings to another point that I also think is missing from a lot of the growth mindset stuff, is that yes, this is all true. So doing lots of bicep curls or running, 3-4 days a week, or trying to learn that language. And we know that we need that repetition for it. But the other piece that I think is also missing is, why would we ever even be motivated to do it in the first place? We need to have this feeling of why I want to do this. And so I think that part of that I've brought into the growth mindset kind of interventions is this idea of self-transcendent purpose. So feeling like we're doing something not just for us, but for the good of the world, or the good of our community, the good of our family, or something bigger than us. Because that sometimes is what helps us keep going, to actually do what it takes to change, because it is very resource intensive and tiring for us.
Oh, absolutely. And then, the neurons that fire together, wire together. And I actually heard this one: neurons that are out of sync fail to link.
Oh, that's a good
And,
one. Yeah.
just kind of going along with it. So when we're not using our resources, we're not linking, and then those pathways go away if we're not
Yes.
practicing something. So
Yeah. It's use it or lose it. Yeah.
yeah.
And another saying is survival of the busiest. The busiest networks survive. Yeah.
Oh wow, it's powerful because especially in the field of learning, we want to really understand new ways to learn, and this is definitely a new way of thinking about how we can improve learning. So it's
Yeah.
powerful.
It's kind of amazing that we've gone so long in education, which is really all about learning and how the brain learns. And yet most teachers don't ever get a neuroscience class in their life.
I know, it was an educator that told me to go this path. He said,
Mm-hmm.
I have a character program that's in the schools, and he said, if you really want to make a mark, you've got to bring in neuroscience to this. And that was 2014, and that's when it all started, because I thought, yeah, of course I want to make a mark. I don't want to just do something with low effort. And he was right. So it's pretty powerful. So we're definitely in the era right now where we're coming around more to the fact that we can celebrate mistakes in the classroom. It's okay if we make mistakes. At least it's being talked about more, that it's okay to fail quickly and often. Can you explain why it's so important from a neuroscientific point of view, like what happens to the brain when we fail and make mistakes, or even try something that we find challenging that we just talked about?
Mm-hmm. Mm-hmm. Well, I mean, part of it is related to what we were just talking about, which is those established circuits. So when we have established circuits, things feel easy. They're efficient. They're pretty automated. We're kind of on autopilot. So whatever we do really well. The thing to remember too is that pretty much everything we do in terms of learning, there is still some type of body component to it. So we also have repetitive thoughts that can just go over and over and over again. But even writing a mathematical equation, or being an artist, or coding for software, there are body movements to it that get automated. So when we get really good at something, we tend to have that somewhat muscle memory, also cellular memory, and those established networks. And so those are the ones that are, pretty down pat. They're pretty automated. The only way, or there's another way to actually think about mistakes, which is that they are literally the side effect of doing something new. And there really is no other explanation for it. So when a mistake happens, it means that there's some small thing was altered about whatever it is you do on autopilot on that routine. And so it absolutely means that a new circuit, something got fired in a new way. So it always means growth. It always does. There is some firing somewhere that happened that was just slightly altered from what you were doing very rotely, very well, and maybe perfectly. But there's always, mistake is a representation of something new. That's literally the only way that something new can get created in the brain, is it has to fire in a new way. And when it fires in a new way, it will not look like something we do automated. It's just that, it's kind of that simple in a sense. And when we look at even how different regions of the brain get lit up as we do new things, and you can kind of viscerally feel this too as you think about it, is that when we do something new, it generally requires a decent amount of attention. So if we think about like learning to drive or learning a new skill, or I even have people write their signature with their dominant hand, so the one that is very automated, and then I have them write with their non-dominant hand. And what you see is there's a lot of focus needed. You can't just do it automatically. You need to be very conscious, very aware, put a lot of attention on that. And that kind of attention is really is related to that prefrontal cortex. So we're getting our prefrontal cortex to be lit up quite a bit when we do something new. And that's it can be quite tiring. There's a lot of blood flow and electrochemical activity that needs to happen, some glucose that, it needs to kind of be used for that. And so but what we see is that as people get very, very good at something and it becomes automated, it becomes, muscle memory or cellular memory, it actually almost shifts location in the brain. It starts to get stored more in the long-term memory areas. The prefrontal cortex starts to quiet down. So it actually, you can see it in terms of the electrochemical activity that's happening in the brain, that it actually, when we're making a mistake, doing something new, there's a lot of effort, it feels hard, and it's going to be kind of awkward. And then as we kind of repeat and get really good at it, it kind of shifts where the energy is located and how it feels. And so one of the key things with making mistakes is that it really is just this side effect. It's literally a side effect of new circuitry being lit up. And so I think it's really important for us to understand that. And that's part of where this growth mindset movement, I think, has been very helpful, is that before, if people thought that, talent or doing something well was you got it in a fixed amount and you either have it or you don't. Now, a mistake is something to be very afraid of, because you either have it or you don't. So if you make a mistake, it means you don't have it, and that's it. There's nothing you can do to develop it. And when we had this more genetic determinism kind of belief, or just this belief, very incorrect belief, that people either were born with something or not, and we didn't have an experience-dependent brain, then it was very scary to make a mistake, because there's nothing you can do about it. If you're not good at math now, you'll never be good at math. And so now growth mindset, I think, has kind of blown that out of the water. It's really got us to look at this idea that no, all of these things are things we can develop. We may not become a prize-winning, mathematician, but we can incrementally develop our own skills because of the nature of our brain. So mistakes, I think that kind of helped make us less afraid of mistakes, because a mistake is just an indication you've left that well-myelinated, well-established circuitry. You've entered some new circuitry, you're lighting up some new circuitry. And so that means you're going to have to keep going. It's not going to be easy and effortless immediately. You're going to have some of that patterned repetition to get better at it. And then the other thing too is we see, so University of Chicago has some research on this idea that around 9-10 years old, I have this on my podcast also, is that students start to believe that effort means, when you have to put effort in, it means you don't have an innate ability for something. It's something that just starts to appear around that age. It doesn't happen as much in the younger years. And So as soon as something feels hard, like the almost the fixed mindset starts to enter the picture. So it's really important for us as models, as grown-up models, to start to really have a new framework for this idea of effort and mistakes, that it is the side effect, it is the indication that you are growing your brain. You are literally lighting up new circuitry. So, and it's not you're born with it or not. Someone who does something effortlessly has just done it many, 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 many times. Are we born with certain tendencies and preferences that make us kind of get better at things and more natural? For sure. But in terms of us developing incrementally our own abilities and things, mistakes are just an indication that we're entering new neural territory. So it's an exciting thing. It's exciting to make a mistake. It means you've done something new.
Absolutely. I love that. I loved that when I heard it, because you can celebrate a mistake. It's like, yay, I made a mistake because I'm growing, I'm learning, I'm moving forward beyond what I knew before. And that's learning.
Yeah. And I would just add to that, because I know Carol Dweck also warns against this also, is that the only thing we do need to also pay attention to is if someone's making a mistake, that is exciting. It means they're doing something new. So that's an important frame to have. But we also, as the educator, as the person who's helping with the learning, we have to understand that if they're continuously making a mistake, there may need to be some adjustments made to the learning environment, possibly to the relationship, to how it's being presented. There's going to be some pivoting that has to happen on the part of the teacher who's presenting that material. So it's not just letting a person make mistakes over and over again, because they might not be actually learning at that point. It's still being excited about the mistakes, but then figuring out if they, continuously make a mistake, what is it that the leader or teacher can start to do to figure out how they can kind of enhance the learning at that point.
Well, that kind of brings me to a question that I had. It ties in about self-regulation. So whether we're a student in the classroom or we're an adult in the boardroom, we all have tasks that we've got to learn. And when something's not working, how do we kind of know how we replicate the things that are working? And then how do we know how to pivot? Do we all need coaches, do you think, or someone looking over our shoulder? Or is this a skill that we can learn ourselves to develop? How would you say?
I would say that, I think part of learning is tolerating frustration. And so I think, I don't think we necessarily have to, our aim may not be that as a teacher, let's say we have students in a learning environment, that they're going to be perfectly okay with every challenge that they have. What I often say to the teachers is, we're maybe not modeling, it might not be realistic for us to model this idea of self-regulation as in, I am totally calm and cool all the time, and that's what I need you to be. But actually, what does it look like when I do lose my cool? And then how do I get back up again? How do I go through frustration and then kind of figure out what to do with that? So it's less about, I think that some people, when they're thinking about self-regulation and kind of being a teacher in that environment, that the expectation is the students and the teacher should be calm all the time. And I think that that's not a skill that they necessarily need to have for the real world. It's more, what do you do with frustration or anger or that? And so a teacher, they're going to sometimes be stressed. They're going to lose their cool. They're going to be frustrated. So how do they model that for the students of what it looks like for this to happen for me? And then what do I do to kind of navigate that? And I do think one of those things is this idea of, so when I talk about self-regulation, I'm thinking also about how things feel in my body. What's the visceral sensation? And a term, and I think you've used it, is this idea of interoception. So one thing that I've used in my own practice, counseling with students, is trying to model for them what it looks like as I objectively talk about sensations in my body that are related to different emotions. I feel like that is one of the keys to figuring out how to navigate those things, because a feeling, a bad feeling isn't necessarily something we want to get rid of. It's information. It's something telling me that I don't like something. Either I don't like how I'm seeing it, or I don't like what's happening. So that's important signals for us to start to get familiar with. And then what does it feel like as I do enjoy learning this, or as I do feel this moment that I understood this math equation? There's a feeling in my body that I'm going to get from that. And the more we can talk about these internal sensations of what it feels like to be frustrated, then what it feels like to learn, and what it feels like to keep going, even though something's boring. If we can start to anchor ourselves in those feelings, I think that gives kids and students a new language to build off of, to help them figure out, oh, I like this feeling of, okay, I got the frustration. I know I felt that, but then I pushed through it. And then I really liked the feeling of overcoming that frustration and getting through that. Because a lot of what we're aiming for is a feeling. We want the experience of things. It's not always, I want the correct answer. I like the feeling of learning, pushing through, and then getting the correct answer. It wouldn't be as fun if it was just automatic. You threw a touchdown every single time you threw a football. The experience of learning and adjusting and feeling, there's an experience of that. So the more we can talk about those internal sensations that we're feeling, I think that we don't need coaches for that, because that's information that we all have in every moment. It's about how do we get more in touch with those feelings as teachers first and leaders first, of this is what it feels like when I get frustrated. And then this is the feeling of kind of working through that frustration and trying this and trying that. That gives us that genuine language to kind of connect with students. So yeah, I don't think we need coaches. We need to be more compassionate with ourselves and what we're going through, to allow those ups and downs and have more awareness of how those experiences feel.
Definitely. Well, I love this. As we bring this all in together, is there anything that you think is important to emphasize about how the brain impacts our mindset, our self-awareness, or our self-regulation that we might have missed?
I think we covered a lot. Yeah, I think, I love really talking about the body and sensations and the sensory motor component. I think that neuroscience includes this idea that our bodies and what we feel in our bodies is a really important part of learning. So I think we talked about that. So,
well, I just wonder, because I heard it from Dr. Daniel Siegel that we have a second brain in our gut, and so many neurons. So is that intuition, our gut feeling? What is that?
They have studied that. Yeah, they have studied that in different things related to intuition and different secretions that are happening in our gut. So some work that's really interesting is from Antonio Damasio and his latest book, The Strange Order of Things. So he basically is highlighting the fact that our gut is one of our first brains. It's the most archaic. It's the most ancient brain. And what's happening within us at all times is we are always aiming to achieve homeostasis. So a balancing of our systems, but also wanting to project forward into the future. And so all of those tiny little signals inside of our body are constantly adjusting and modifying it and trying to figure out what we prefer, what we want to avoid, what we want to get attracted to. And so the gut is part of that system. There are all these little fluctuations that are happening constantly in our body. And the gut is, just the most kind of ancient part of that system of what we prefer, what we don't prefer. And there's information there. So there's like an interaction with the bacteria. I think there's more bacteria in our gut than there are cells in our body. So they are communicating as an organism also with us. And then our heart is a really big one that I've been doing some work on. Our heart has a lot of information. And what I like about Antonio Damasio's work that really parallels with how I'm seeing things play out is that we keep acting as though the brain is the one that kind of makes the decisions and kind of has all the information, but it's actually more the other way around. The gut and the heart and the viscera, like the inner layers of the skin and all that, they are sending signals up to the brain. And the brain is then processing that and creating associations and then kind of giving signals about what to do with it. But there's actually 80% of the fibers that are going up into our vagus nerve and the brainstem that gives our brain information are sensory fibers, meaning that 80% of the information, like the flow of information, is 80% from our body and from the sensors in our body, including our gut, to our brain. And then 20% is the signals from our brain going back into our body to tell it what to do, which means that our body has so much information, and the gut is a really, really big part of that. So yeah, I think that listening to our gut and listening to our heart, and I have been doing that lately with different meditations of really focusing. I focus a lot on my heart, how it feels in different meditations. And there's a lot of information we're seeing from research about what the heart is telling us, the different patterns and rhythms that it's doing. There are actually these things called sensory neurites, which is almost like brain-like cells that, the gut and the heart are telling our brain a lot. So it's really important to listen to both of those.
Oh, it's so interesting. I just heard someone talking this morning about that our heart slows down when we're meditating, and it's all connected. And we've got to learn to listen to what we're hearing in our bodies. But we weren't taught how to meditate. This is all stuff that we have to do ourselves.
Yeah. There's really beautiful research from that. There's different rhythms. So there's like different hertz and frequency ranges, and there's meditators that can get to a really, really low frequency that is related to, when we're in our mother's womb, there's certain frequencies that are more familiar to us. The delta and the theta are really familiar to us when we're in the womb with her. And we can sync up with our mother's brainwaves also when we're there. So there's something very, if you think about it, very nurturing about that idea that when we meditate, we are kind of going back into some of our first rhythms, the very first rhythms we had when we were first born, or not even born yet in our mother's womb. So yeah. There's very cool research coming out about that.
So interesting. We could just keep going, but I want to thank you so much for taking your time on a weekend to speak with me. This topic is of such high interest. I know that it's going to get a lot of interest. Thank you so much for diving deep to help us here. And for anyone that wants to learn more about you, I know you've got a TED Talk that's highlighted on your website, StefanieFaye.com. If anyone wants to go check out your TEDx, what do you cover on your TEDx?
Well, the title is Humans, the Most Experienced Dependent Species. So talking about how our prefrontal cortex develops over childhood and how it really, really matters, how we are nurtured in our relationships and the experiences we have that kind of affect how we react now, and that there's change is possible, that our brain can change. That there's a lot of circuitry that we can develop as we grow. So the experience-dependent brain.
Well, thank you so much for your ideas, insight, and your research.
Thank you. It was an honor to be here. Thanks so much.